Okay, so you're happy these two are slightly trickier, right? So, have a look at the first one. We've got x minus 1 on y minus 4y equals 0. We've also got x minus 6y minus 1 equals 0. By the way, you notice both of those things are equal to each other. Because if this thing equals 0 and this thing equals 0, it means they must equal each other. They must be the same as each other. Why would that be a bad move? Why could I not just go x minus 1 on y minus 4y equals x minus 6y minus 1? Why could I not do that?
Tried it, didn't work.
Good, good. But why? Why did it not work? Well, have a look. What did we do with the first two examples? What did we try and do?
We tried to put the x in the side.
Yeah.
So we can put the equations together.
Okay, so we tried to get rid of, we tried to put them together to try and create one equation. But more than that, we didn't just try and create one equation, we tried to also do something else. What do we try and do? Why could we not solve this as it stands?
Because there's a divide.
Okay, so there's a divide y, but that's not necessarily the issue here. How many variables have I got in this equation here?
Because you got two variables and you only got one equation, so that's unsolvable.
Absolutely, yeah. So you're happy. Here I had two equations here, and when you try and put them together, you always try and get rid of at least one of the variables, okay? So here, I put them together because they're both equal to 0, but are you happy that I've still got x's and y's all mixed together? Yeah? It means I can't solve it, right? I can't solve equations like this because I can't get all of the variables on one side and the variable on the other, because I just like x and y on one side, numbers on the other, it wouldn't solve, okay? So when you're trying to put these equations together, always bear in mind, you're not just trying to create one equation, you're also trying to get rid of either the x's or the y's, or whatever variables you're using. So you need an equation with only one variable in. Whereas this equation has got x's and y's, it's no good, right? So what could I do instead? Can't set them equal to each other, what else could I do?
You can use the, I don't know how to say it.
Subtraction.
Like, I can do it, I don't know how to say it.
Okay, so talk me through what Riley's done. So first things first, you've numbered both of these equations, which I think is definitely a way to go. I think that's really good, okay? You don't have to, but it just might make it a little bit easier later on to keep track of how you got each thing. And then you said, okay, let's have a look at equation 2 first. So you said, okay, equation 2, I can rearrange that to just get x on its own. Yeah, and can you see how she's done that? Just added 6y and added 1 to both sides. So I said, okay, equation 2, x equals 1 plus 6y. That's equivalent to this. Just get all of the things which aren't x on the other side. Okay? And you've also had a look at equation 1. And you've gone, you're like me. It looks a bit messy, right? The reason why it looks messy is because you've got this divide by y. You've got this fraction. So how could you rearrange that equation such that you get rid of that fraction? Times by y, exactly. So to get rid of divide y, you have to times y, but the condition is you have to times everything by y. So if you times x by y, you get xy. If you times 1 over y by y, you get 1. If you times 4y by y, you get your 4y squared. And if you times 0 by y, you still get 0. Yeah? Perfect, well done. So now you've got these two equations. So you've got x equals 1 plus 6y, and you've got xy minus 1 minus 4y squared equals 0. If I gave you these two equations at the start, hopefully you would have been a little bit happier with me. Because you'd be like, okay, this looks a little bit more friendly. I can do something here. Okay? And then Riley, you've basically said, okay, x equals that. So therefore, in the second equation, whenever I see x, I just replace it with 1 plus 6y. Does that make sense? So you see an x there, hence you write 1 plus 6y times y. Minus 1 minus y squared equals 0. That's how you get that line there. Is that okay? Good, okay. And then you just expand this out, so you get 6y squared minus 4y squared, which is how you get your 2y squared. You get 1 times y, which is how you get your y, and you still have a takeaway 1 on that side as well. Okay. And then you just solve that as you did before. So hopefully you got, so let's set it up. So you get 2y, it will factorise, plus 2, no, plus 1, take away 1 here. Yeah? Just to factorise it, because -1 times +1 makes -1. 2y times 1 makes 2y. Take away 1y, it's just going to leave you with +1y. Okay? And therefore you get y equals 1/2 or y equals -1. Yep. Then of course you know x equals 1 plus 6y. So if you do 1 plus 6 times that, what do you get? 6 times 1/2 is 3, add 1. Okay, good. And then you do -1 times 6, which is -6, plus 1 is -5. Perfect. Sorry, that's x equals. Okay. Now, just a word of warning. When you've got two sets of solutions, so you notice here you've got a y and a corresponding x, and a y and a corresponding x. Always try and match them up. So, for example, do not do this. Do not go y equals 1/2 or y equals -1, just like you did here. And then you go, okay, so then x, well, it's -5 or it's 4. Yeah? You're happy that doesn't make sense because that doesn't match with that and that doesn't match with that. So always try and keep them matched together. Remember that these are coordinates. They're the intersection points. Okay, so always try and make sure they're matched up. So the first one comes with the first one, the second one comes with the second one. If you have a third one, it has to come with the third one, and so on. Is that okay?